Hello, I want to welcome everybody to our monthly webinar series designed for CMI and by CMI. I'm Cynthia Howell and I'm from Colorado School of Mines and I'll be your moderator today. I'd like to tell you a little bit about the webinar. Again, we are hosting this and broadcasting from Colorado School of Mines. If you have a suggestion for a future webinar, we're always looking for that because these are designed for you, our CMI team. So if you have a suggestion, make sure that you put it in the ending survey and or contact us via email. This is a public webinar and recording is going to be available in about a week, it will be next week at aimslab.gov/CMI under the workforce tab. And also, we are going to be using the question and answer mode, and most of you are very familiar with it and have been doing that with all our other webinars. And generally, we wait to the very end for questions. We may pause after about the 8th slide to see if there are any questions real pertinent to those first initial slides, as well as answering at the end. I want to introduce our guest today and our presenter from Western Rare Earths. This is Marty Weems. He is a global executive his experience goes across 20 countries, 5 continents. He has a double master's in business and science. And his experience is across the board as well with businesses that are with artificial intelligence, to startups, to healthcare, and of course to critical materials. He is now at Western Rare Earths, and they're doing projects in Wyoming and Arizona. And he leads the development of critical materials in an environmentally and responsible and sustainable way. And that's very important, as you'll hear as he continues on with his presentation. I don't want to take any more time. I know we'd all like to hear from him. So Marty, if you wouldn't take it away from here.
Will do. Thank you. All right, to get my screen sharing in order. And we came in on the wrong slide. Let's go there. There we go. Thank you, Cynthia.
You're welcome.
All right. Let's make sure we have my audio correct. And all is set. So thank you everyone for attending today. Thank you, Cynthia and Maureen, for establishing this. Thank you to our friends at Lawrence Livermore National Lab for introducing us to the Critical Materials Institute. Really honored and humbled to be able to present to such a fantastic group. Thank you to everyone that's on the webinar today for listening in and watching and having interest in what we're working on here at Western Rare Earths. I think we bring a bit of information to share. We also bring a lot of questions and looking to learn from other folks within CMI and the related institutes. So happy to be able to share what we have and what we're working on and use it as a means of invitation to collaborate further with other members of the institute. So Western Rare Earths, we're focused on critical minerals for renewable energy, green tech, electric vehicles, national security, and a carbon-reduced future, while onshoring jobs into a opportunity zone area in Western Arizona, as well as in Southeast Wyoming. We have a third project in development in Nevada as well, but our real flagship is the Arizona project, with Wyoming shortly behind. After the lawyers require our appropriate disclaimers around any forward-looking statements. So there'll be some of these slides that I move through really quickly. I think the audience here today probably knows a fair amount about the industry and some of the uses of these technologies. So certainly key drivers here on the projects with which we're focused are permanent magnets that are primarily neodymium, praseodymium in their critical material content, as well as scandium. Here you see a handful of those uses for those raw material inputs. Why now? What are the real market growth drivers? There's certainly some national security issues at hand. The Department of Defense, as well as Department of Energy, have identified these particular materials as being critical supply chain elements for national security as well as industrial security. But the so that has created a lot of interest and a fair amount of news flow across the industry. The real market pullers here, the drivers, is going to be the renewable energy industry, especially electric vehicles, permanent magnets there too, and then the use of scandium potentially for lightweighting. We think with Rio Tinto stepping into the scandium production landscape, it'll make scandium aluminum alloys a much more common available material in the market, as opposed to it being just this rare exotic that it has been in past decades. So we see, some good government push as well as market pull on specific materials. I want to be specific. I don't want to imply that there's some grand shortage of rare earths. That's really not true. Lanthanum and cerium are almost excessive in their availability, and they're by far the largest volume of rare earths of lanthanides. But we're very much focused on the magnet metals, heavy rare earths, and scandium. There might be an opportunity for hafnium in our Wyoming project. So, we're very specific on what we're after and what we're trying to accomplish. There's been a fair amount of government support in the critical materials space, and it has. I often tell people that the Trump administration really took down some barriers, removed some of the drag and the hurdles relative to trying to accelerate a project such as this. And the Biden administration is putting things in play that are really generating demand going into this deeper into this decade and beyond, with the renewable energy focus, electric vehicles, and offshore wind, the advancement of solid oxide fuel cell technology, all of these things. Quick company overview. We see ourselves as three projects on one platform. So it's a couple of hard rock mining feedstock projects, as well as developing, processing to support that and advance that. We see having a key role in the U.S. defense industry supply chain and reducing creating some independence from China's rare earth stranglehold. But as a function of total market, that's not an extraordinary volume opportunity, but it is a critical one for our national defense. But the big market, as I said earlier, is green tech, clean tech supply chains, and we want to do that in an environmentally responsible way. We have specifically focused on deposits that have a very, very low incidence of radioactive penalty elements in the deposits. Uranium and thorium being incredibly low, beryllium basically non-existent. These are penalties that exist with a lot of the more common high-grade hard rock mining rare earth targets, especially in North America. We see an opportunity for using renewable power. Arizona is one of the leading states for renewable power production, low water utilization and water recycling with these projects. Both the Arizona and Wyoming project are either fully or partially in opportunity zones, which creates a bit of a tax haven for the U.S. tax investor. That can be very attractive to attracting capital into these projects, because they do need a lot of capital to be stood up. We have a great support from our parent company in Australia, American Rare Earths Limited. And here in the States, we put together a really diverse and inclusive board leadership team, and have begun to accumulate a really strong technical leadership. So we're excited about what we've built and where we're going. So to that quick overview, I talked a little bit about our assets being hard and really focused on these very low penalty elements, and beginning to collaborate on disruptive processing technologies with CMI partners. Market growth, I've talked a little bit about, and we feel like we have a focused strategy going forward. These stage one items we have solidly behind us and established. Stage two, we're really working hard on it here in this year. And stage three will be getting closer and closer to permitting and production. So now kind of the key pieces of what I think is, for today's discussion, we see it as there's a traditional approach to rare earth mining in general, processing in general. And we think that's ripe for challenge. Traditionally it's been this big and rich approach. Investors will support projects of high tonnage and high grade. Because that is industry standard, especially in precious metals and other metals mining. It makes sense. It's very logical. The old adage is grade is king. So these high grade projects get prioritized. And with traditional processing technologies, the industry was really forced to focus in that area because recovery efficiencies have not traditionally been all that extraordinary. Other rare earth projects, quite often the lanthanides or the Lone Ranger. Some projects around the world are pulling lanthanides out of some sort of waste stream, or they're mining something else in a primary position. We think to stand up a rare earth lanthanides focused mine with the lanthanides being the only thing available, that's going to be a really tough thing to accomplish. There needs to be some help in something else in the deposit, ideally. So we do think, current approaches are essentially kind of this fruit of the poison tree. Bastnäsite, monazite, these are high thorium content deposits, and effectively, one might call them thorium mines with the side of rare earths. So we're not looking to chase that. We see thorium has no really good place to go. There are plenty of great ideas about what to do with thorium and, energy production and all kinds of things. I don't want to discount them, but as it sits right now, there's just no executable options near term. Also under a Biden administration, when you look at the prospect of opening new radioactive mines under Biden, or standing up new producers of radioactive material or waste under the Biden administration, I'm not going to say it's impossible, but I think that's a pretty hard row to hoe, and is going to bring pretty exceptional challenges unto itself. So here's where we came at this approach. We're looking at for hard rock rare earth. First, do no harm. Let's try to avoid high thorium deposits. Mineral sands, high grade hard rock deposits in North America are traditionally also with high grade comes high thorium. So in looking at alternative hosts, coal fly ash can certainly look attractive. In the lab, it looks really attractive. The prospect of really economic capture of the feedstock. There's a lot to like about using coal fly ash, especially the lignite. And some of them, not all of them, great. The problem is where they are. You're looking at sites, locations that can have their own little rotten Easter eggs and EPA violations just waiting to jump up and grab you if you take control of a particular site such as that. So they are, we think there could be some good options in the landscape to that effect, but they're tough to find. So that brings these allanite hosted deposits that we found in La Paz County, Arizona, and Albany County, Wyoming. So that's where we brought our focus. They're low grade deposits, but we think they get economic in pretty short order. Additionally, we wanted to find a sidekick with some bling. Our Arizona project has scandium. Our Wyoming project may have opportunity for hafnium and zirconium. Both of these states are known for their gold deposits. So, there could be other things that lend positive economics to these projects that we're developing. And then emerging processing technologies, which brings us to our involvement with CMI partners, and we think that's critical. So we see the need to replace some key sections of the traditional processing flow sheets. And it's probably not a technology. It's probably, the real answer probably lies in a new tech stack that interweaves some traditional processing and beneficiation, along with likely multiple new technologies. some deployed sooner rather than later because the downstream opportunities have to evolve as well at the same time as we're bringing these things forward. I won't get too much into the details of the realities of VAT penalties where the current rare earth refining capabilities are. But being able to be sensitive to that and adjust our outputs and our economics as a function of how the downstream processing capabilities evolve and where that happens, and things like VAT tax implications there too. We see emerging ways to navigate that in a kind of a stepped algorithm that has some positive outcomes. And then we see DOE and DoD funding, especially through CMI lab and university partners. If we can be a feedstock partner to some of these emerging technologies, and that puts us in a preferential position to utilizing them down the road, we think that's a very worthwhile investment in these emerging technologies. So there's some new tech that we're watching. Land modulin, it's out of Penn State, being worked on by Lawrence Livermore. Bacteria biosorption, there's some interesting published research around that that's come out of Lawrence Livermore. CLEX by Lexivia, a group called Rethunk, some carbon nanotube thin film separation. UCLA, Dr. Wang's stuff out of Purdue University, Dr. Honaker's stuff out of Kentucky. And I'm sure there's a longer list here that I don't know. And that's a lot of why I'm here today. We want to make more of these connections. We want to learn more about these emerging technologies from the ones here, as well as the others that we haven't listed here. The filter through which we're trying to look at these is, we're looking for things with ultra high efficiency, scalable simplicity, fiscally responsible, low water, low energy usage, renewable, reusable, environmentally friendly, and ideally something that's feedstock agnostic. If there's, given any particular feedstock, if it, can have a pre-processing to get it to some reasonable common state of some, say, a pregnant leachate solution, or something that can be commonly entered into a process, that is really encouraging to us as well. And yes, I realize I'm describing the purple squirrel of mineral processing. So, it's there aren't a dozen of these lying around to pick up easily. It will take some public-private partnership. It's going to take really great work by members of the Critical Materials Institute in order to bring forward, advance, prove, and scale anything that looks like this. So I'm going to pause right there in case we have any questions that have maybe popped up yet. Let's see. All right, nothing. I checked the Q&A and nothing yet. So we'll wait until
Not
the
quite
end.
yet. Yeah.
Okay. All right. So I'll tell you a little bit about now our projects, where they are and why we like them. Our La Paz, what we call the La Paz project, is in Western Arizona. It's over 5,000 square acres of land holding. It's got a fantastic road that runs through the heart of the site project. So the infrastructure is really extraordinary. There's high voltage electricity just a few miles to the southwest, and rail access just a little bit beyond that. Arizona is a really fantastic place to be developing a mining project. It's actually ranked number 2 in the world by the Fraser Institute as a mining friendly jurisdiction. Then we also happen to be in a really remote area of Western Arizona. There's no competing use of this land beyond essentially off-road ATV use. And, we're looking to cooperate with folks of that are interested in that, in that recreational activity, that, we don't end up ruining important pieces of land that, that they'd like to have access to. We want to be responsible partners in the community. So, we see it as an ideal location. The congressional representative for this district is one of the most mining friendly, pro-mining congressmen, serving in Washington currently, and we see that mindset continuing into the future. So this map shows a little bit of, where our maiden resource is up in this red circle area. It covers about 500 acres of the project area. We're really excited by the prospects down here to the southwest as well. Surface sampling down here has shown, comparable grades at surface, both in lanthanides and scandium, as we have found up here in this area in the maiden resource. So, could be really substantial opportunity here in the general area. Currently, we have a drilling program going on with core material coming out of the ground this month in March that will go towards stage 4 advanced metallurgy work, with some partners, both in lab partners, both in Canada as well as in Australia, that have some really fantastic rare earth processing experience. But on the right here is where we'll be looking to establish actually a new maiden resource for just the scandium as a function of this drilling that's happening literally this month as we speak. And we've also found really legitimate scandium grades here in the areas to the southwest. So it matches up quite well of our scandium discoveries, at least at surface, as well as the lanthanides discoveries. Our Wyoming project, this is in northeast Albany County in Wyoming, another really fantastic mining-friendly jurisdiction. Both of these projects are exposed at the surface and lend themselves to really cost-effective open pit mining. Here you can see the kind of the location of this and some sampling work that's been done up to this point. This project is really interesting, and especially in the while it may be seen as a low grade total rare earths project, when you look more closely, the grades of the magnet metals, neodymium, praseodymium, dysprosium, terbium, is actually quite comparable to the other leading projects in development in the US, as well. And the heavies are actually comparable, if not superior, to the other leading projects in the US. But the thorium content is still remarkably low. The in situ thorium content, I believe, is less, uranium thorium combined is less than 65 parts per million. So in the La Paz project, the combined uranium thorium is less than 8 parts per million. So that's what makes these projects really unique, in that this is feedstock that doesn't show up with a lot of complication. While it comes out of the ground low grade, it concentrates really simply with crushing, pulverizing, and magnetic separation. We can set aside, probably 90–95% of the material pretty quickly and cost effectively, so that what ultimately goes on to flotation and then ultimately to leaching is a really small percentage of what's come out of the ground. That sets us up really well for a mine reclamation plan later on that has an extraordinary amount of the material that's never been chemically treated and can therefore go right back in the hole. So we don't end up with just extraordinary volumes of heap leach and other waste material. Our wastes, our tailings, should be really quite manageable compared to a lot of other rare earth projects around the world. Here's some of the grades included here. I won't wade through these, but you can see how the Wyoming project has really strong neodymium and praseodymium grades, but we're not fighting the thorium battle. So, there's been some initial processing and concentration work on the Laramie project, that we call it the Laramie or Wyoming Rare Earth Project. So again, it concentrates pretty readily and straightforward through crushing and magnetic concentration, meaning we have much less material that we have to deploy expensive advanced processing against. Value proposition, we see global demand. We see a focus in our metallurgy of these 4 key magnet metals, the heavy rare earths and scandium especially. And then, we think government intervention, this declaration of a national emergency by the Trump administration, and now the Biden administration really pressing forward on research and, and driving a green economy that's going to demand these materials pretty dramatically. Just a real quick comparison here. I keep talking about the uranium thorium. Here you can see our Arizona uranium thorium combined 7.2 parts per million, Wyoming just over 60 parts per million. It's compared to a couple of other pre-revenue comparisons in the landscape, but a project in Texas, another project in Wyoming. But of course, the Australia Linus project, much higher uranium thorium content combined. We bring this the sidekick with some bling with scandium, and we also have multiple mining project locations here. Although I do believe the folks with USA Rare Earth have picked up a few new partners and are exploring new additional locations as well. I don't want to disparage any of these other players. We'd love to see a lot of cooperation in the industry between partners, but between producers such as ourselves or what, future producers such as ourselves. We wish them every success. We think there's plenty of room in the market for multiple producers. So no one project has everything that the market will need. So it's going to take multiple producers so that we can provide what these supply chains ultimately need. A little bit of our structure. Our parent company is American Rare Earths Limited out of Australia. Western Rare Earths is the U.S. holding entity and now it holds La Paz Rare Earth, which is an Arizona company, Wyoming Rare USA, and we've just recently started this project in Nevada. You can see some of our structure and our leadership, a lot of mining experience here that complements my business experience quite well. I love that we have Melissa Sanderson, formerly of Freeport-McMoRan, 15 years international government relations VP for Freeport-McMoRan Mining. Dennis Geldard, mining engineer. Clarence McAllister, engineer, CEO of engineering company here in Phoenix. So just some really great diversity and experience on this board. A little bit of media, some links to those, and then pictures of all the leadership team, and I'll wrap it up there. So good time now for some questions. I'll open the Q&A box.
Marty, you do have a couple of questions ready to go.
Yeah. So let's see. How does the property? How's the rare element resources property in Wyoming compare? That's a great question. So the Daniel is asking about another project in northeast Wyoming and how it compares. So the Wyoming project compared to our Arizona project is certainly a higher grade project, but it also has challenges with thorium challenges, as you'd expect from a North American high grade project. I am really impressed mostly by the work of the rare earth element resources folks in northeastern Wyoming. They've done a fantastic job of partnering with General Atomics on the processing technology. They sent some ore to Europe and really advanced, done some good work there. They're doing some exciting things, and we're certainly watching them and paying attention, and they've got some good things going. So it's on the positive end, it has some pretty decent magnet metal content and at higher grade. And some good processing technology seems to be coming along for them as well. Yep. All right. Dr. Zhao, who I know from Lawrence Livermore National Laboratory, says, "Thank you, Marty, for the great talk. Thank you to the whole supply chain for delivering reed from allanite to electric vehicles. What keeps you up at night based on what we know and what Western Rare Earths have explored so far?" Great question. Mostly what keeps me up at night is having one more cup of coffee after 11 a.m. But for the most part, I actually sleep quite well, mainly because I am so impressed by the folks that I meet and speak to and learn from at places like Lawrence Livermore National Laboratory, Penn State University, Purdue, University of Kentucky, all these places that are just doing fantastic work in the rare earths processing space. to help us solve this supply chain conundrum that is in front of us. You know, I believe, the big problems, when you think about it, is it's feedstock, it's processing, and then and it's capital. I think we have some good feedstock opportunities that we bring to the table. I am really excited about the technology I see coming forward on the in the emerging technologies front. And as these things become more known, the investment community is going to show up with the capital. So, quite honestly, I sleep pretty well. I see a lot of really fun challenges. We got a lot of work to do, a lot of things to figure out. Man, I really like our team. I really like our team. Thank you for that question, Dr. Xiao. Next is Bradley. What is the host rock for the La Paz deposit? Is it the red bed tertiary upper plate rock, weathering of underlying gneiss? Good question. That's someone who knows their geology probably a lot better than I do. But the primary host is an Ogden gneiss for the lanthanides, specifically an allanite grains held therein. The scandium seems to be a bit more ubiquitous to the gneiss. Those tertiary red beds, the upper plate, the grades are not as strong. As we get into the lower plate area and into that Ogden gneiss, and where the allanite grains are more in higher concentration, that's where we get stronger grades. Which has driven us to now, with this current round of core drilling that we're doing now. Previous drilling in Arizona was only to 100 feet. It was extremely shallow to be able to establish a maiden resource for much of anything. So now we're going down to minimum 200-foot depth. That drilling is actually where we've been able to follow the geology going even deeper than that. So, we're quite excited about the potential results that will come out of this upcoming drilling. And being core drilling, we'll get some good assays and some good metallurgy work that'll come out of that. So I'm excited to learn more from what produces there. Thank you, Bradley. Daniel, will water recycling technology be important for mining and processing? Wow, great question, Daniel. I've lived in Arizona for 14 years. Probably the favorite Arizona joke is that in Arizona, whiskey's for drinking and water's for fighting over. So we have got to be extraordinarily good stewards of any water that we use here in the state of Arizona. So water recycling technology will be incredibly important. We're looking to use the minimum amount of water possible. And then whatever water that we do use, we're looking for every opportunity to recycle and clean that water, use it over and over again, and get the most out of it, so that we are excellent stewards of a really valuable resource here in the state of Arizona. Thank you, Daniel. Kevin asks, is Western Rare Earth's goal to produce separated rare earth oxides? If so, do you envision co-located separation plants at each project location or a central processing location? Really great question, Kevin. So our eventual goal, as the market evolves and the downstream processors, takers, manufacturers put us in a good position to produce separated rare earth oxides, I would be very excited to do that. And that is a part of our ultimate plan goal. Do we come out of the gate doing that? Most likely not. So, but it's a key part of what we're doing, of what we're trying to work towards. Currently all of the refiners, if you produce in the current market landscape, if we produced separated rare earth oxides of the lanthanides, they would have to go likely to mainland China for refining. There'd be VAT tax on that. So, we'd have to be selling it, minimum 13% below market value plus shipping costs in order to be competitive in that landscape. That's a little tough way to go. If we produce a mixed lanthanides output that goes as raw material to those refiners, there is no VAT tax penalty. Now, I think that changes over time, and we get we get to a position where we're, not chasing that. And we could potentially work with, say, a partner like Eutectics that's here in Tolleson, Arizona, who, if we do produce, say, especially say high purity scandium oxide, they could turn that into scandium tape. And that could maybe be taken by a solid oxide fuel cell producer like Bloom Energy. So these are all hypotheticals. I'm not saying that's, what will happen. I'm saying that is certainly a hypothetical path that we see as potentially viable. Next one is from John. Thanks, Marty. MP Materials claim greater than 7% grade. It appears your sites are at less than 0.5%. How can you compete just on the basis of digging the stuff out of the ground? Great question. On the basis of just digging it out of the ground, that's going to be problematic. The folks at MP Materials sit in California. It is a much more expensive place to do the mining business than is Arizona. We look to have a very cost-effective open pit mine. Open pit extraction in Arizona costs between $1.50 $2 a ton just to get it out of the ground. The really great advantage we see on the metallurgy front here is that with simple crushing, pulverizing, and magnetic concentration before it's before flotation, before leaching, we get to a much higher grade concentration of what actually gets processed. So as we get a little farther down the, if you make comparison of size and grade at the level that it's in the ground now in situ, it doesn't look very appetizing. And that's the reason this project has been overlooked for over a decade. Everyone looks at the size and grade sheet and says, oh, wow, that's kind of a ridiculously low grade. But that was before we figured out the ease of magnetic concentration of this deposit, as well as the scandium bonus that's in there. So that's how we see as the ultimate economics putting us in a competitive position. Okay. Next one's from Tom Hunt. Do you think the increase in rare earth battery metal recycling technologies and companies affects reminers on the competitive landscape? Well, I think to say no would be foolish. It's absolutely going to affect it at some level, but there's also the reality that aluminum has been recycled for a long time, and at this point, given the landscape of recycling in that world, it's pretty minimal, especially compared to, and is not going to accelerate in any extraordinary way on the near-term horizon, at least by my limited knowledge of that space. I would love for us to stand up a processing facility that is effectively a part of the rare earth recycling supply chain. In an ideal world, if you think back to I think it was slide 9, our ideal processing technology that we end up utilizing would be feedstock agnostic. And with that, in an ideal world, I see, as windmills come out of are decommissioned, that some of those rare earth permanent magnets could come into be pre-processed and become feedstock for our ideally feedstock agnostic processing facility. So I'm hopeful to be a part of that recycling technology supply chain, as well as using more direct feedstocks out of our mining projects. All right, Tom is back with another question. Let's see, what do you think the most applicable green renewable technologies are for your assets? Solar and wind for heating electricity, hydrogen ammonia for machinery. What have you explored? Great presentation. Thank you. Hey, thank you for saying that, Tom. I know I can answer the first part better than I can answer the second part. The hydrogen and ammonia for machinery, honestly, we're not far enough along for me to really speak to that in any meaningful way. If it's, economically viable and environmentally friendly, the short answer is yes, we want to explore that. To the first part of that, where you say solar and wind for heating and electricity, Arizona is one of the most solar friendly environments in in North America. We have a fantastic solar opportunity here, so we'll absolutely be exploring that. And we see that in partnership potentially with the, say, Arizona Public Service, which is the big electricity provider here, that we can partner with them on that, as well as potentially stand up some solar capability on our own as well. Great question, Tom. Thank you. And then Sinan, I'm sorry if I'm not saying your name correctly. Where do you see the government's role in enhancing U.S. supply chain security, including with regard to extraction and processing? I think the government has done a remarkably good job in actually being first focused on processing technology and figuring out, let's figure out the hard problem first. So I applaud the work they've done. I applaud the money they've set aside for research in this area. We want to be supportive of that. We're fans of public-private partnership, through CMI partners especially. So the government's role definitely needs to be very laser focused and heavy on the R&D side of things and figuring this out. We don't want all this, all this IP to be tied up in patents in mainland China. We should be leading this as a nation, especially the U.S. and its allies, Canada, Australia, and others. We should be leading the technology evolution related to these, the renewable energy future. So any way the government can help facilitate that, both directly and indirectly, it would be fantastic. As well as there's an opportunity for the government to remove some barriers, as well as provide some appropriate funding. I don't think I'm not going to stand here and say the government should be throwing large amounts of money at deposit folks for the sake of a mine. We're going to figure out the deposits. I do think them spending time understanding the complete landscape of potential feedstock opportunities, not just the traditional high grade feedstock opportunities, but also be it coal fly ash, as well as feedstock opportunities such as the ones that we're trying to develop that are a little less traditional. Great question. Thank you. Yoshiko, are there deposits of this type being mined for rare earths anywhere else in the world? The only other allanite projects that I know of in development are, there's a group called Search Minerals in Canada. I believe the folks at USA Rare Earth have recently become involved with them as well. And their deposits are also partially allanite hosted. I don't know the grades off the top of my head, but that's the only other ones. For the most part, most rare earth projects are ionic clays, or or some other or a bastnite. It's either a monazite hosted. It's either a monazite deposit or a bastnite deposit, that are, especially of ones that are in production and ionic clays. All right, I think we punched out all the questions so far.
I
Thank
think
you,
we have. We do have a little bit of time for another question. However, until that comes up, I'd like to thank you, Marty, for a great presentation.
Yeah, thank you.
It's great to see how Western Rare Earths is working on extraction of critical minerals for green and clean technologies, defense industry, and so on. I'm going to take one moment. I'd like to thank you for attending today. I'd like to thank you for attending today.
It's like we have one more late question.
Yeah, good, great question. Is WRE interested in becoming a CMI partner? Yes, 100% so. And we're actually looking to move that forward here quite soon. Thank you for asking that. And Sadan, how do you see China responding to U.S. efforts to increase domestic rare earth supply? Um, at the at the risk of making a really ridiculous prognostication here, I think I've spent a fair amount of time in mainland China, and I've actually done business with Chinese government entities in the past. Um, it will be very thoughtful. It will be measured. It will have any response they have will be, will have a very long horizon in mind. Will be very strategic. I think they're working really hard to um, produce and record patents at an extraordinary rate relative to utilization of rare earth inputs. And potentially those will be used to kind of maybe paint us in a box down the road from a processing and technology utilization perspective. Um, the Chinese are, they're looking to protect jobs, and they're looking to protect a key industry, and they're doing what's in their national best interest. And it's they will not go quietly into the night relative to this. They will look for levers and look to deploy them that will create some challenges. I like our odds. I think Warren Buffett said I wouldn't bet against American innovation anytime soon. So while it will not be easy, they will create challenges, and there will be many other challenges on the landscape. I, I, I like our team that includes CMI partners, and I think the rare earth materials, critical minerals landscape for the U.S., North America, and its partners is quite positive, and I look forward to being a part of that. So I'll close from my perspective with just a really heartfelt thank you and an open door. Feel free to contact me if you see you have technology capabilities that we should be looking at, thinking about. We'd be excited to learn more about those. Thank you so much.
Thank you so much for a great presentation. I'd like to thank the attendees today. Again, if you have a suggestion for us, please don't hesitate in the future. Join us for the next webinar on April 21st, Machine Learning for Microstructure Modeling, a Data-Driven Pathway. And that's going to be presented by Fei Zhao out of Lawrence Livermore National Laboratory and Ming Tang, Rice University. Of course, everything can be found in the critical materials and at aimslab.gov/CMI under the workforce menu. And again, Marty, thank you for a great presentation and overview of your company or the work that you're doing in Arizona and Wyoming and how CMI can be a part of that. Thank you so much.
Thank you.